What is a tessellation? A tessellation is taking a shape, repeating it over and over again, and completely covering a surface, completely covering a plane. Another word for tessellation is a tiling. The cheese slices on this sandwich tessellate the plane, but more on that later. There are different kinds of tessellations. The first kind of tessellation is a regular tessellation. A regular tessellation is made of regular polygons. There are only 3 regular polygons that tessellate the plane: triangles, squares, and hexagons. You can see this type of tessellation in a lot of different places. This is a picture of some Kleenex boxes stacked up at Target, and if you look, we are creating a tessellation of triangles. Here's a picture of some floor tiles that are hexagons. These hexagons tessellate, completely cover the plane. Here's a golf ball where each dimple is actually a hexagon. So why don't other polygons tessellate the plane? Well, if we look at a tessellation of pentagons, 3 pentagons fit together, but a 4th pentagon won't fit in the empty space. So the reason that other polygons don't tessellate the plane is they don't fit. They don't cover the plane. Another type of tessellation is a semi-regular tessellation. A semi-regular tessellation uses a variety of regular polygons. There are only 8 semi-regular tessellations. Here's a semi-regular tessellation of hexagons and triangles. Here's one of hexagons, squares, and triangles. Here's a picture of all 8 different semi-regular tessellations. Here's octagons and squares, squares and triangles, another version of squares and triangles. Here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dodecagons and triangles. Here's another tessellation with dodecagons, squares, and hexagons. And here's one with hexagons and triangles. These are the 8 different semi-regular tessellations. Here's an example of a semi-regular tessellation. We have an octagon and a square. This is actually the pattern on the inside of a jacket. You can see the zipper down towards the bottom of the picture. Other tessellations. Other irregular polygons also tessellate the plane. Parallelograms, rectangles, rhombuses, trapezoids, scalene triangles, right triangles, isosceles triangles, and kites. Which leads me to the subway story. This is a letter that I found on the internet that I like to show my students. Dear Subway, your cheese slices are shaped like this, isosceles triangles. This is great because it allows you to tessellate the cheese across the sandwich like this. Beautiful coverage, life worth living. However, you guys never do this. Instead, you always arrange your cheese like this. Unnecessary dairy overlap, soul-crushing disappointment. Please stop doing it like that. A number of years ago, I showed this to my students, and I had a couple students go to Subway and ask the worker to tessellate their cheese slices. About 6 months after the students asked to tessellate their cheese slices, Subway changed their policy to always tessellate their cheese slices. So now, when you order a sub at Subway, you will always get tessellated cheese. And the last type of tessellations that we're going to look at are artistic tessellations. You can take regular and irregular polygons and modify them using different transformations to create unique designs. An example would be this design. This is a variation, a transformation of a rhombus. And this is actually the print on a mattress. Here is a transformation of a rectangle, and this is actually a picture of a notebook. The artist M.C. Escher became famous for his tessellation drawings. Here's an example of a triangle tessellation, which he turned into a man and then tessellated the plane using that man. Here's an example where he took triangles and turned the triangles into birds and then eventually had the birds flying away from each other. This is another variation of that same picture, but this time he started with squares, and the squares morphed into birds flying in opposite directions. Right here, these birds tessellate the plane. And here's my all-time favorite M.C. Escher drawing. This is a drawing of a tessellation based on the hexagon, where the lizards are coming to life and walking around. There's a lot of neat things in this picture, including this shape right here. If you notice, this is actually a pentagon. We talked about the pentagons not tessellating the plane. In fact, if you connect 3 pentagons together, it actually pops into the 3rd dimension. Pentagons tessellate in 3D. We can tessellate pentagons all the way around to create this 12-sided shape. This 12-sided shape is called a dodecahedron. Do means 2, deca means 10, so a dodecahedron is a 12-sided 3-dimensional shape. And here's an interesting picture. This is the self-portrait of M.C. Escher. Instead of just doing a normal self-portrait, he decided to do a self-portrait of himself looking at a sphere. So if you look, this is the room that he's in, drawn, looking into the sphere, with this being his hand.